Well, well, welcome to the Oscope Wizard. I'm Gabe, the Oscope Wizard. You have joined me on Baby Friday. Thank you very much. I really appreciate it. I've got my putty here that I use to hold down um, wires and connectors in my hand, squeezing it compulsively. That is because I'm having so much trouble measuring current on this Raspberry Pi 4. Why? Why am I having this trouble? Well, hmm, maybe we should get right into it. Right into it. I am wearing a band shirt, even though it's not Band Shirt Tuesday, but I missed Tuesday's show. And we're combining Baby Friday and Band Shirt Tuesday. It's a big day. It is a big day. Let's go over to the oscilloscope. I have the oscilloscope out and hooked up today because I am going to try to use it to make some measurements. I'm going to try to make some measurements. Let's turn on my setup here. I have start my timer. Let's try to keep on track a little bit if we can. The chat says measuring current is hard, but measuring current is even harder. Did I spell current incorrectly? I probably spelled current Currant. Oh my goodness. I'm sure I did somewhere. And chat is trying to help me. Let me know where I made that mistake on spelling. Miss Stevens, my high school English teacher, would be shocked and ashamed. Oh my goodness. I'm trying to measure current on this thing, and last time we tried to do it through a series of adapters and converters because the Raspberry Pi 4 uses a Type C connector, which is, oh, chat's just making a bad pun. Okay, I feel better. Thank you so much for letting me know that it was a bad pun because I had a real terror moment that I had spelled current incorrectly somewhere. And anyway, I couldn't take the abuse. Back to actually trying to measure current or current. Wait a second, is C-U-A-A, say, can I even spell? C-U-R-R-A-N-T. Is that like a current, like a raisin? Isn't that a thing that become raisins? Current. Yeah, it's the fruit. Thank you. You're right about it. Mr. Lewis is in the chat. He's trying to help me. He's trying his best to help me. But we were measuring the current using these adapters. So I have some USB adapters, which I use all the time on the show. And this is my Type A. And this is my micro, which was the adapter previously used on Raspberry Pis. And now they've converted over to the Type C, so I had all these machinations to go from micro out to Type A, and then a Type A to Type C adapter, and that was plugging into the Raspberry Pi. And over here I had another cable that was coming in to this adapter from Type C into it. Anyway, I was getting a lot of voltage drop. And also, this only has power, 2 data lines, and ground. Although the micro has some other ID line. But on old USB connectors, slow USB connectors, previous to high-speed USB, previous to USB 3, this is USB 2 connectors, you had power, data, ground. Now, let's look at this Type C adapter. This is a Type C adapter I bought. And it has got so many more connectors than the old USB adapters. And I was curious if the Raspberry Pi is actually using some more of this capability that comes with Type C. And let's go to the browser really quickly because I have a pretty good website explaining what the big difference is. So previously we were using a 2.0 interface, which has data data, data plus, data minus, it has ground, and it has V-bus or power. Now USB Type C has, of course, USB 2.0 because legacy, everybody still has all these cables, all these components that still use USB 2.0, and they want to use them with their computer. So they just kept tacking on wires. So I have a TX and I have an RX. That's my high-speed path for USB 3. I also use that path for DisplayPort. And also Thunderbolt, I think. I think Thunderbolt uses that as well if you have a Thunderbolt-enabled computer. You still have V-bus. You have a sideband data connector, which I'm not sure. I think the sideband is used for DisplayPort and Thunderbolt, but it is not used in the USB standard. And then you have these communication channels, the CC lines, which communicate. It tells the cable if it's plugged upside down or right side up, or compensates for how you plug it in. But it can also do power delivery communication, which I am curious if the Raspberry Pi 4 even utilizes that, because they were real big on forcing you to buy their fancy Raspberry Pi 4 power adapter. And I thought that was probably because they were using power delivery, USB power delivery, but I'm wondering if it's not. I think the reason they want you to buy this is because it does 5.1 volts. Can it even find it? Can you find it? There we go, 5.1 volts and 3 amps. So it uses a little bit more voltage than 5 volts, 5.1 volts, and 3 amps. The Raspberry Pi 4, I guess, could pull up to 3 amps. That's it can be a little bit more power hungry for sure. But I find it interesting that every other USB adapter is 5 volts. Like, this is my beefy adapter for my Ultimate Ears Bluetooth speaker. And it can do a bunch of different voltages. It can do 5 volts, it can do 9 volts, and it can do 12 volts. And it must use USB power delivery to determine what voltage it's going to send out. But I don't think the Raspberry Pi uses USB power delivery. And I figured an easy way to check that would be to, hey, let's throw on some scope probes. So I have some scope probes connected to this little breakout board. You can see my 2 scope probes. One is connected to CC1, one is connected to CC2. I'm going to plug that into my logic lines on my scope. I'm just going to see if they toggle. Does anything at all happen when I plug them in? And does it affect the voltage? I'm a little disappointed that USB-C power delivery doesn't seem to be possible, since this only does 5 volts. It does do 3 amps, so it does 15 watts instead of, previously it was only 10 watts because it would be 5 volts, 2 amps. Oh no, my screen disappeared. I disappeared from my screen. That's not awesome. That is less than ideal. Well, you know what? Let's get it out of there real quick. We'll scooch it over. That's really weird, guys. Why did I disappear? Why did I disappear? At least my microphone still appears to be working. So strange. So strange. Let's go. Okay, so we have I just plugged in the Raspberry Pi. I'm curious. I'm going to unplug the power from the Raspberry Pi for a second, and I want to plug in my MSO cables that I'm using with my oscilloscope. I have a whole mess of cables, and I also have my power rail probe so I can measure the voltage rail. When I was using this breakout board over the last couple of days, just getting ready to see how it's going to work. Does it work well? Does it work poorly? Get a lot of voltage drop across this breakout board, and the way I can tell that is because A, the Raspberry Pi occasionally reboots, which is a bad sign, and B, the Raspberry Pi throws up that little lightning bolt in the top right corner of its screen indicating that you're under voltage. It's never a good sign if you're trying to do something with the Raspberry Pi. Okay, so I'm plugging in my MSO cable, plugging in data line 0 to control line 1, and I'm going to plug it into ground over here. I'm kind of using a really ridiculously long ground wire because it's just more convenient. Isn't that the case all the time when I'm making measurements? It's like I'll take convenience, just like in a real lab, I'll take convenience over proper measurement technique. The proper measurement technique would be to solder the ground wire directly onto the closest point that I'm probing. Not what I'm doing, though. Not what I'm doing. Now, let's go over to the oscilloscope. Now that I have this plugged in, I'm going to go over to the oscilloscope. Part of me wants to fix my my camera a little bit. I think what I'm going to do is make this a little bit smaller. And maybe I will move this up. So there we go. There we go. So now you can see what I'm doing over here, and you can see my oscilloscope screen. First things first on the oscilloscope, let's preset it because I was clearly doing something kind of weird. And channel 1 right now is my power rail probe, and I am curious to see what the power rail is going to be so I can turn on my probe meter. That's what I'm going to use to measure my voltage, and then I think I'm going to minimize that, get it out of the way. Get it out of the way. The next thing I want to do is some digital lines, MSO. Come here, MSO. Come here, MSO. Why can I never figure out how to turn the MSO on through? I can never figure it out. How do you turn on the MSO without hitting the button? Does anybody know? Does anybody know? I don't know how you would know. Parallel bus. There we go. Parallel bus. Hidden cleverly under the parallel bus instead of MSO. That's okay. That's okay. Let's make my threshold. So my threshold is 1.6 volts. I'm not sure what the CC line is, but let's make it low. Let's make it manual, and we'll make our threshold 0.5 volts. So anything detected in a very small voltage range, it will trigger. And you can see the lines in the background are going up and down occasionally. So D0 is occasionally toggling, and D1 is occasionally toggling. I could even, let's change my trigger to D0. There we go. There we go. And you know what? Let's zoom out so I can see these digital lines. Parallel bus. The chat's agreeing with me, like parallel bus probably should have been digital, but beggars can't be choosers. We're gonna need a lot of time because this is a slow speed bus. Okay, I can see it toggling. I do see it toggling quite a bit. I wonder if that is too low. Does the internet know what the voltage level of these CC lines should be? Type C, CC lines, each Type C has 2 CC pins so that it will always be connected, and you can tell when it is upside down or right side up. There's a resistor in there to pull it up or pull it down, blah, blah, blah. Huh. It does allow me to negotiate higher currents. You know what? On the scope, there's actually a, if you can believe it, there is a decoder for USB power delivery. Let's check out the decoder for the scope and see if that'll give me some hints on what the voltage level should be. Okay, it looks like the data is transmitted. The data is right in here, 600 millivolts. So it does look like it uses a lower swing, which makes sense because there's a pull-up resistor and pull-down resistor telling the devices which one is going to be the source and which one is going to be the sink or the current, and telling the devices kind of, I think it tells it the max power handling capability. I can't remember. My USB Type C knowledge is low. Oh, did I accidentally turn it on? I don't want to turn it on right now. Let's turn it off. Where did I turn them off? Where'd they go? No, don't turn off. Oh my goodness. Come back, parallel bus. Oh no, they're completely gone. Let's unplug it and replug it. We've hit a snafu. Snafu hit, and here we go. Something we did made it really angry about what we had done with the parallel bus. Oh my goodness. The joys of test equipment. Every piece of test equipment has its own little foibles. I suppose I should probably preset because I have changed quite a bit. Let's turn back on the probe meter. All right, so no power is happening right now because I don't have the thing plugged in. Go back to parallel bus. Let's turn it on. D0, D1, solid. And we will make it manual. We'll make this a little lower. So we'll make this point. So the decoder wants 0.6, whoa, not 0.6 microvolts. That's very low. What am I doing here? 0.6 volts, 0.6 volts. Here we go, not 0.6 millivolts. That's next level tiny. Next level tiny. All right, let's move these over. We can actually, I think we can actually make these a little bit larger here. Cheating and using the knob on the front because I can reach it. So we do want to go back and we'll trigger on D0, trigger on the edge of D0, and then back to grabbing a ton of time. I don't need 40 gigasamples a second, but I do need a ton of time. Let's see, a millisecond. Can we make this lower, like a gigasample? There we go. There we go. Now I got some stuff happening. I suppose if it is actually negotiating, we should see the voltage. We should see, should we see I'm wondering what's going on these channels right now while it's not plugged in. Like the power brick is plugged in the back. I suppose it's constantly pinging to say, when are we going to talk? When are we going to talk? Plug it in. The lines go completely silent. Strange. We're at 4.3 volts. This is my problem when I go through this whole contraption of voltage drops into the Raspberry Pi. The power brick is outputting 5.1 volts, and the Raspberry Pi is receiving 4.3 volts, which is making current measurements very difficult because the Raspberry Pi never wants to boot up. In fact, let's see if it is booting up. We can see real quickly. Oh, it did boot up, but it is very low on voltage. One of the things that I thought was I could bypass half of my adapter when it comes to voltage and plug right into the bus of the Raspberry Pi and see how that affects this voltage number right here, this 4.3 volts. I guess I can copy to offset and we can bring the signal back over. Also, you'll notice it doesn't really seem to be using power delivery too much. If I unplug this, I guess it's going to go back out, and it is trying to talk. It's like, yo, 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 where you at? Where you at? I wonder what happens if I try to analyze this. Let's just real quickly see if it will do that. Serial bus. Let's do USB power delivery and make it D1. Let's see what it thinks of that. Test frame, test frame, test frame, test frame, test frame. How about D0? Test frame, test frame, test frame, test frame. Lots of test frames. Oh, I guess it probably is just out there looking. Like, where are you at? Where is anybody there? Please. Oh my goodness. Oh my goodness. Okay, okay. This is like
5 minutes left. I was 5 minutes left.
oh, and there's where I'm supposed to be. I'm supposed to be here. Oh my goodness. Here we go. Here we go. I don't know why my camera's not working. Let's set our timer up for 5 minutes just so we don't last too much longer than our prescribed time. Start up our timer here, and I'm going to bypass this half of the power path. So on here, I want to unplug V-bus and ground. So that was my blue and my brown wires over here. I'm going to disconnect those. Let's get a better view on the camera so we can zoom it in so you can see exactly what I'm doing, what kind of bad choices I'm making. I'm making bad choices over here. Here we are. So I have disconnected. This is my V-bus and my ground. I'm going to real quickly disconnect my, here we go, disconnect my power from my wall so I don't accidentally whap it. Whap it. Now, I'm going to measure V-bus, I guess, over here on this side, which will be not ideal. I'm going to disconnect, you know what I'm going to do? I'm going to disconnect my NeoPixel for a second because it's not really part of this measurement. And I'm going to connect my blue wire from my Type C connector to V-bus on my Raspberry Pi, my brown wire to ground, and then I'm going to measure the voltage right here. I suspect this is going to have way less voltage drop when I bypass all this extra wire. What will it do to the operation, though, of my Raspberry Pi? Will it have better power? I guess I can plug in my... Okay, so now to plug in, let's make it small so we can A, watch the smoke come out, and B, there we go, is it right over here so we can see? B, we will see if it powers up, and will the smoke come out? I hope the smoke doesn't come out. These Raspberry Pi 4s are more expensive. Okay. Yes, look at that, 4.95 volts. Copy to offset. There's my signal right there. I am not communicating on the CC lines. It didn't communicate at all, did it? Did it do any communications at all? Yeah, okay, this is smarter. So let's zoom out and get a little bit more time. A little bit more time. Let's get a couple of milliseconds. Let's get maybe 20 milliseconds. 20 milliseconds. That's a lot of milliseconds. and we are going to do a, we want our trigger position horizontal reference point. Let's make this over here at the 10% point. So that means it's going to start way over on the left-hand side of the screen. And left-hand side of the screen. Okay, so now when I hit single, we'll see if any communication happens. Are we using these CC lines with this Raspberry Pi 4? Nothing. My scope. Did it trigger? No, it still says single here. It still says ready to go here. Oh, dude, I got trigger set to auto. That's not right. That's not right. That makes the scope trigger whether you wanted it to or not. Normal. Feels like when you hit single, it should probably know that I don't want to be auto. All right, we are waiting on trigger. There we go. We finally, the scope wizard is wizarding his scope slowly but surely. Okay, so there we go. What does that do for me over here? What do we got? Okay, we did actually use some power delivery. Look at that. We could can we zoom in a little bit here? Let me zoom. There. It's tough on the it's tough using a mouse to do it. Now let's see if we can analyze that. Let's analyze serial bus. Turn it on. Oh my gosh. Oh. It does look like it is using power delivery. The Raspberry Pi doesn't use power delivery. Nope. We've confirmed it. Chat confirmed it. The Raspberry Pi, let me see if we got it here. The Raspberry Pi does not use power delivery. Chat's trying to tell me that the Raspberry Pi doesn't use power delivery. Also, my computer apparently doesn't want to use that camera over there. So sorry, computer. I'm glad the chat confirmed that the Raspberry Pi doesn't use power delivery, but we also confirmed it with the oscilloscope, which is cool because that's what the oscilloscope is there to do. It is there to help you verify your designs and make sure they're working properly, and also maybe fix something that's broken. That was the show, guys. I'm going to hang out in the chat. We're going to do some stuff next week where we actually get the voice detection to work and output text to the LEDs. I actually have it working in practice on my test bench right now. I have some different programming algorithms to write, which I don't want to do on camera because that's kind of boring to watch, but I would love to have like the process figured out, and we can talk through it and figure out what algorithm I chose and why. So next week, don't forget Band Shirt Tuesday. I don't know all the nerds in the world, and I would love to meet them, so please share this with a nerd in your life, and I will see you guys later. Bye!